All right, welcome back. Let's go ahead and get started, everybody. If you'll notice, the clock in the back is now correct. Yeah, that's kind of a specialty of mine, changing clocks, because they're right there. Okay. So last time I was really unhappy with how we left the conversation about extra credit. So first of all, I got to apologize to you. So that was a result of me just not having been able to take the time to think through all the details. And so this is how we're going to change things. And I think that it should make everybody happy, all right? Item number one, everybody's paper report no longer has to be 5 pages, but 4 pages. And now you love me, right? I'm the best. Number 2, you'll understand why in just a second. Number 2, if you, so I have changed the survey, the Google form, so that you can go back and edit your responses. Because what I want to do is I just want to know if you want extra credit or not. Okay, so this, okay. So we're going to kind of do 2 rounds of things. All right. So first, we need to figure out. We're going to figure out which papers the graduate students and the honors contract students are going to present on. That's kind of most important to me, so that we actually have that line. Once we have those settled, which won't take very long on Friday, tomorrow, because the forms closes tonight. So please go back and if you want to change your answers, do that tonight. Once we do that, we're going to figure out if you want to do extra credit for this assignment. You have 1 of 2 options if you're not a graduate student and you don't have an honors contract for this class. You can either give a presentation on a paper that has not been selected for being presented on, or do a second report, and that's the reason for the page reduction to 4 pages. Okay. So that also opens it up for honors contract and graduate students. If you want to do a report, a presentation, and another report, you can also get extra credit. So that's
still extra credit for presenting.
Yes.
Yes. When do you have to decide?
Today. Well, no, not today. So I'm going to send out another Google Forms after we've collected. So the Google Forms for the paper report still closes tonight. Okay. We're going to settle who is presenting from the graduate students and the honors contract students. By the way, if you're an honors student but don't want honors credit for this class, you don't have to present. Okay. I didn't make that clear before. It's only required if you want to do an honors contract for this course. Okay. Does that make sense? Yes.
So we can submit like an honors contract using the description. That's fine, and then sign up for the presentation.
Yes. Yes. So the only way to get an honors contract, though, is by doing a presentation. The numbers that I've collected, the things that I've seen as far as like on the roster and everything, tells me that there should be plenty. Right? There's only 2 graduate students, like 2 or 3 or 4. I can't remember the exact count. There's only a few graduate students, and so there's still lots of papers up for being able to present. Okay. Any questions about this new direction? Yes.
If we indicate that we're interested in extra credit and then decide later down the line that we're not interested in extra credit, we
so that's one reason why I opened up the form for you to go back and edit your answer. I prefer that you do that now.
Okay. Tested out the papers due, like April, so like now I don't know if I need extra credit, but I need to I'm interested, but then like April, might not.
So, let me say this. Like 9 of the 12 papers are really cool. The others, so I don't want to like badmouth the other 3, but they're like more technical and a little bit less exciting, but still really important to be aware of forensics, right? So by doing an extra report, you're gonna be able to pick, these are good papers, right? I pick them either because they're exciting or because there's stuff you should be aware of. So what I'm getting at is just err on the side of, if you think you're going to need extra credit, and I know at this point you have 0 homework assignments, 1 fake pop quiz, and no test to base your decision off of. And I get that's difficult, but I never liked having 2 midterms, and I personally don't like grading lots of tests. So it's a win-win for us to not have had a test. So that was my really long-winded way of saying, you gotta make this wrong. Yes?
I also wish they would be reserved.
Nope, not going there. But they're definitely not the ones that are mine. Yes?
How much extra credit is it for doing a presentation or doing 2 court reports or?
Dang it, you're not supposed to ask that question. No.
It's like 1 point.
Are they equal?
Oh, are they equal? Yes, they're equal. Yes.
You should weight it more towards the presentation.
Why?
It might convince people to do it more.
So here's the thing, right? So grad students and honors contract students, I'm making you do a report and a presentation, right? I thought about that. I kind of went back and forth a little bit. We're taking more time on this than I wanted to, but once you've written a paper, like a report on it, making slides out of that is like really. So if anything, I would go the other way, but I won't. Any other questions? Yes.
Just to clarify, so we can take a presentation or another report, right?
Yes. Yes. But here's the thing. I've got to have 12 presentations. So we'll figure that out when we come to it. Maybe next week, once we have settled this out a little bit more. But I've got to have 12 presentations, 1 for each. Might have this week, but hopefully won't. I didn't say that a lot. Yes.
Presentation's 20 minutes.
I believe so. It's in syllabus. Any other questions? And again, I apologize for not having settled on these details earlier. Okay, let's talk about projects. Any issues with the project? Anybody having? Yeah.
The examples mention a blockchain file. Are we supposed to be loading something in from like a file system?
Yes, it's it's something that your program creates, so it's not something that I believe the details are in there. It says that did I give a file name?
No.
Okay, either send me an email or post on Piazza and I will correct that. Any other issues, questions about the project? So far, anytime I've had someone come talk to me about the project, I'm like, oh, that's a really good point. I'll adjust the project description to make it more clear. So please let me know if you have questions. Okay, just a quick heads up. Assuming that lecture today goes well, you have two homework assignments coming up in the next couple lectures. So hopefully I'll announce one today and then again on Tuesday. I will give you enough time to do them. But we're finally there. Okay, I'm really excited. So just to build up your blood pressure a little bit. Yeah. Okay, let's do a quick review and then get into today's lectures. What is a partition? Yes. Yes, a collection of consecutive sectors in a volume. Very good. What is a volume? Yes. A collection of sectors that are addressable. So that's the one difference between partition and a volume. A partition, they're consecutive. They just keep going from the perspective of the partition. And a volume, they're just addressable. They don't have to be consecutive. Very good. True or false? From the file system's perspective, different partitions are treated the same as different devices. True. So in Windows, you'll go in and you'll see the C drive and the D drive, the E drive, as many partitions as you have that Windows can see. It sees them as different drives. So, yeah, very good. How many partition entries are in an MBR or can be in? Yes, 4. And what are the 4 critical pieces of information in a partition entry? What are the 4 critical fields? It's not that tricky. What do you have to know if you're going to find a partition? Yeah. Was that a finger?
I was
counting. You're sucking me out. Okay. Yes.
I think it has to do with where it starts and where it ends.
Yes, that's 2. Very good. What are the other 2? Yeah.
Type.
The partition type. It's very important. Yes.
How big it is?
Oh, we already said that.
Is that kind of?
The length. Yeah. One more. Whether it's active or not, the 00 or 80. Yeah. Okay, very good. So, okay. This one's a little tricky. How many bytes in the MBR are reserved for the boot code? How many bytes are reserved for the boot code? It's kind of important. Yes.
512.
No. That would be the entire record because the master boot record takes up exactly 1 sector, which is 512 bytes. So, yeah. 446. Very good. You'll see why that's important in just a little bit, okay? All right. And what is the successor to the MBR? Yeah.
GPT.
GPT. And why? Why did we need a successor to MBR?
Because I think MBO has a limit on how much space. I think it's like a terabyte or 2 terabytes.
Yes. So size limitation and also just so GPT is like way more flexible than the MBR. So that's another huge advantage. Come on. That's weird. 1, the other one coming? You can do it. All right, so last time we talked, we were talking about, let me peek here. So we were talking about master boot record and specifically we're doing volume analysis, right? So we're gonna wrap up our discussion on volume analysis and then hopefully introduce your first homework, your first programming assignment. All right, so what's going on? This projector just doesn't like me or something. I don't know. Okay, I apologize. So sector addressing. Just a quick note on this. All right. I as far as addressing sectors go, there's a couple different perspectives that we have to consider. This is very distracting. May I at least mute it? Mute that one, right? And I can't even turn it off. So, great. All right, the logical disk volume address. So this is relative to the start of the volume. So on the disk, if we have one particular sector, it has multiple addresses, right? We have the CHS address, we have the LDA address, but then we also have an address relative to the volume in which that sector belongs to. So we also have the logical partition volume. So not just the volume, but also the partition. There's a relative address that's relative to the start of the partition. So say we have a disk that has two partitions with kind of a gap in the middle. And just for argument's sake, this wouldn't happen in real life because the first sector of a drive has what? A little more confidence. Just talk about it. Master boot record, always. The first sector of a disk is always the master boot record, always. Because that tells us we have to know the layout of the rest of the drive, right? So we have to have information about how the rest of the drive is laid out in the very beginning, okay? Master boot record is always the first sector. So this is notional, not realistic, okay? But partition 1 starts at address 0, that logical block address. And we have partition 2 that has a starting address at 820. Again, notional, there's nothing special about the number 820. So if we have a sector here, its logical block address is 100. The logical volume address, which is going to be the same as the logical block address because we're not like continuing on a volume from another partition or another drive, is also going to be 100. And the logical physical volume address is also 100. Whereas if we have a sector, oh, by the way, we have this gap here in the middle, starts at 650. So that means there's a gap from 650 to 820 between these two partitions. Okay, so we have this other sector in partition 2. It's logical block and logical disk volume address, so relative to the volume, are both going to be 920, but the logical partition volume address is going to be 100 because that's relative to the start of the partition. Questions? Yes?
Why is it 920 and 820?
You can work that out. Think about it. What is 820? No, yeah, but what is 820? So the partition 2, 820 is starting address of the partition.
Oh.
And this is sector 100 in that partition. Yeah, it was a little too obvious, right?
Yeah.
Yes.
So would there be a situation in which the LVA and the L2VA would be?
Yes, so the logical block address and the logical disk volume address can be different if you have multiple disks that are part of the same volume. Remember our discussion last time about logical volumes, right? So you can have multiple disks part of the same volume. So just because you're at the beginning of the disk doesn't mean that's the start of the volume. You could have had other disks, other partitions that came previous. Does that make sense?
So in that logical volume, you could have two repeated logical block addresses then, because they're two like separate physical disks.
Yes. Yes, you can have two logical block addresses repeat in the same partition. Yes. They were a totally different layer. We've got lots of layers of abstraction, right? Yes.
So that'd be the same volume in the same cylinder, it's a different disk.
So cylinder is at the physical level. We're talking at the volume level and at the partition level. So The volume and the partition don't know anything about cylinders. They just know they have a string of addressable sectors, right? So does that answer your question, or are you still?
No, that answered your question.
Okay. Any other questions? Okay. Once it clicks, you're like, oh yeah, that's pretty intuitive. But sometimes it takes a minute. Yeah.
Last time I think we discussed, so logical volumes can span multiple physical disks.
Yes. Yes. Any other questions? All right. So when we're going to analyze a partition, here are the steps that we need to take. First, we have to locate the partition tables. That makes sense because that tells us, well, we know where the MBR is. We know where the partition entries are. By the way, I may use the term partition entry and partition table interchangeably. They're the same thing. Okay. We've got to find the partition tables tell us where that partition lives in relation to the physical media of the hard disk. So then we can process the data structures to identify that layout, so we can get the offset. It's important to discover the partition layout, of the whole volume, because not all the sectors need to be assigned to a partition. You saw back here in this example, there was this gap, right, of 820 minus 650, I don't know what it is. The sectors, right, they're not part of a partition. They're not assigned to any partition. They're just kind of floating out there, not being used by any file system. So these gaps can contain data from either previous file systems that did occupy that space, or it could be that a suspect's trying to hide information, so they put it there and then chop off their partition. There's lots of different things that could happen, okay? So identifying the layout of these partitions is actually an important step to forensic analysis of a partition. So we're going to conduct some consistency checks, look at the last partition and compare the starting location with the end of its parent part or previous partition. Okay, and we also do consistency checks to determine where else evidence could be located. So in order to analyze the data inside a partition, we've got to know what kind of partition it is. Most of the time, it's going to be a file system, because there are other cases where it could be swap space or a database, which is has completely different structure than a file system. But we need to know that. We need to know what the structure is inside of it as well. Any questions? Yes.
Is there a way to retrieve this information if the first sector of the disk is damaged?
So that is a great question, because that's another reason for the GPT. So the GPT doesn't rely on one set of entries. There's actually, it duplicates itself to the end of the disk. So you usually just use the GPT entries at the first part of the disk, but if in case that gets corrupted, you have the backup at the very end of the disk for that exact reason, because MBR, there's no backup MBR. So the fastest way to make data irretrievable by the novice user is to overwrite the first 512 bytes of a disk. Yeah.
If you were like a malicious actor trying to hide your activities and you overrode the first sector, or in GPT scheme, if you overrode the first area that the GPT has and also its duplicate, is there a way for us as investigators to like figure out where the data is, or are we just kind of shooting in the dark?
Yes, there are ways. It's definitely more time consuming than to have something point to a location and say, this is where you need to start looking because there's no data before there, and it goes to that point. But basically what it comes down to is you're looking through the whole data in the whole file for the file system structure, right? So these structures are pretty identifiable, and so if you're looking for it, you can find them. You just have to look through everything. You don't have a good starting point. Does that answer your question? Any other questions? Okay. So, as we just mentioned, you've got to be familiar with the layout of the entire volume as pertains to the partitions, so that if there are any gaps, you need to extract them. If you're doing a logical extraction or a sparse extraction acquisition, both of those are focused at the partition level, not at the volume level. And so if you do one of those kinds of acquisitions, you're going to need to manually go in and use DD or some other tool to go in and slice out those pieces of information that are in between partitions. Okay, that's basically what's on this slide. Any questions? All right. Let's do some analysis, shall we? Okay, well, actually, we're not good. That's for the next slide. All right, so this MMLS tool, it's really handy. Wow, that looks terrible. This is one of the things that I don't like about Google Slides, is that sometimes, every now and then, the layout just totally fails you. Give me 1 second, because that's what it normally looks like. Okay, so we'll just use this for this particular slide. Okay, so MMLS is this tool that basically it reads in your MBR and spits out the format of the disk. Right. So you can see here we have slot 0 is just the partition table. It starts at sector 0, ends at sector 0 with a length of 1. So this is just the MBR. The first primary partition, it's 62 sectors long, and it's unallocated. So that actually is very common for the first 63 sectors to not be used. It's actually very common. Okay? Why? 63 is actually a very common number of sectors per track. So it just meant that the very first track, not the whole cylinder, but just the first track, they would stick. Okay. So we have Windows 95 FAT32, and then a space that is unallocated before we have a BSD partition. So basically, you have start of the volume, and then FAT32 starts, and then have unallocated space, and then open BSD partition, and then you want to extract these 62 sectors, and then these 1542240 sectors. These are the commands with DD that you would run to grab them off the disk. Okay, so MMLS tells you where you need to manually grab that information, and then DD is how you would actually pull it off. Is that clear? Any questions? Yes.
Can you explain it?
Yes, you can install DD on Windows. MMLS, I don't remember. Well, you'll notice the hash mark, right? So the difference when you're in a Unix compatible system, if the prompt starts with the $, it means you're just a regular user. It's got a hash, super easy. So this, no, that's a real term. I'm not making that up. You have elevated privileges on the system, which is what you need if you're going to directly access, well, that's on, anyway, yes. Any other questions? Okay, let's fire this back up. Sorry, give me 1 second. Apologize. Isn't that crazy how far off it is? Okay, I will fix that before I save it to PDF. Promise. Okay, here we go. Everybody got your pencils out? Let's do an exercise. So, here we have the last several, we have a slice from the MBR. Now, remember that the first, how many bytes of the MBR are reserved for the boot code? 446. Now, you don't, I'm not going to require you to remember that number, but here's how you get there if you ever need to. I haven't taught you that yet. No, we'll get to that. Okay. So, your job right now in this exercise is to identify the two partition tables in. Man, I was expecting to be able to have two projectors. This isn't going to work without having two projectors. It's like on, but it's not on. Can't tell what's going on.
It was working when you were in percent.
Working. Yeah, it was flickering more.
Hey, it actually turned off. That's a good thing. Sorry, people on YouTube, we're having technical difficulties with the projector. Okay, hopefully that'll come on and just magically work, because otherwise this exercise is really difficult to do. Okay, so we've got two partition tables here in this data structure. Now we're at 432 and 448. So that means we've got to go back 2 bytes. So these 2 bytes right here are part of the first partition table entry. This isn't going to work without my two projectors. So I need to show you the structure for you to decode the structure. Okay, I want everyone to raise their right arm like this. And repeat after me. I state your name. Do solemnly swear that I will do this exercise on my own. What? No, say that. I want you to know. I want you to say it. Thank you. What?
Can you like take a screenshot of
That's what I have ready for you, right? So, but you got to be able to see all of the bytes, and if it's too small, then you can split it. Let's see. I'm looking for this. So this is what I have. I mean, it will kind of fit. Is that good enough? Can you see that well enough?
Yeah.
Okay, let's do that. Yeah, it's actually a little bit better because then it's viewable on YouTube. We'll just take a couple minutes to do this because I still want to announce the homework today. So there's 2 partition tables in all those hexadecimal numbers up there. I want you to decode it and tell me what the values are. Okay, what's the flag of the first partition? Inactive. Yes. Next.
1.
Okay, actually, the next thing I want you to, so this is why there's a problem. So what I'm looking for actually is the flag type, start sector, and size. Okay, so what's that? Just read it while I move it around. Come on. What's the type? Just give it to me in hex. You don't have to convert it to decimal. Who can see it? you can see it, raise your hand. Don't go blurting out the answer. No, it's fine. No, it's okay. No, it's okay. So let me step you through this one, okay? So the fastest way is, you see here, the offset says that it's 4 bytes off from the beginning of the partition table entry. So if right here is where our partition table starts, then we just go 1, 2, 3, 4, 0, 7 is the answer. So I should have started counting at 0. I'm so sorry. 0, 1, 2, 3, 4. 0, 7 is the type, which happens to be, well, we'll get that in a second. Okay, starting sector. What is the hexadecimal value of the starting sector? Just raise your hand when you have it. Sorry, I should be clear, is LBA. Okay, tell me what is the offset to find the starting sector? What's the offset to find this value that we're looking for?
3F. When you say LBA, do you mean
8 is the offset.
LBA?
It's LBA, and the value is 3F. 3F.
Is it not the whole thing?
It is the whole thing, but it's a little endian. So all those zeros that come after 3F are actually before 3F, so 0, 0, 0, 3F. Yeah,
You asked for the absolute sector, right?
the starting sector, yes.
Which is not necessarily figured out, right?
The number of sectors between MBR, which has a logical block address of 0, and the first sector in the partition. Worded kind of tricky, but that is the starting sector. Yes.
So the beginning of the partition for cylinder sector is different.
I'm sorry, say that one more time.
The beginning of the partition for the cylinder/sector is different from where the sector starts.
Okay, we're not doing CHS stress, LBA. So all the stuff in byte offset 1 and 2 and 5 and 6
RC.
don't compare. They don't. They're 0 anyway, right? And it's easy. So they're, yeah. We're looking for LBA, which is right here. Okay. Yes.
So the way the little endian works here is the sizes of them are in little endian, not like the whole thing.
That's correct, and that's an important thing to keep straight in your mind, because what I have down below, that tells you the data structure, right? It doesn't tell you the content. We don't know, when we're looking at the data structure itself, we don't care about little endian until we know if it's a numerical value or a string value.
So once we say, okay, first sector in partition, and see that it's one double word, so then we know it's in little endian, and then we.
So what tells you that it's in little endian is that these are all numbers. These are all integer values.
Okay, so we see it's the size of the word, and then we're like, okay, it's a number, so this.
So the size of the word tells you the length of the field.
Right.
So you need three things, right? You've got the, so every data structure has three components: the name, the offset, and the length. Right, so the name tells us what we're looking for, and then the offset tells us that we need to come to right here, and the length tells us we need to read till there. That's what the data structure tells us. Now, we also need to know the type of data that's in it. That's number 4. We know it's an integer, little endian, so we gotta reverse the bytes. Yeah.
Where does the offset value start at? Is it at the end of the MBR?
So this, very good. So this is not, this is within the partition entry. So if you were reading through the MBR, you would seek in 446 bytes. And then from that point, the offset from relative to that point is where you would have used this value here in the offset column. So an offset from by 0 to 446, right? And this is 447, 448. Yes. So this 448 here tells us that at this point we have. No, I can't do arithmetic. So this is going to repeat once we read in all of this up to here. So from 0001 all the way to 1F00, that to there is one partition entry. So the second record from here all the way to there is the second partition entry. The offset value is going to be the same.
Right. So the value that's at offset x08 in our instance was 3F.
Yes.
Right. That 3F value tells me the distance to the beginning of the partition from what point? From the end of the MBR. Right, between, says between, which means it's the end, and you asked for the absolute sector of the partition. So do I need to take 3F plus 5 club to get the absolute sector?
Okay,
Or would be 5 12 would be plus 1?
I feel your frustration because newsflash, professors don't create all original content, right? This is an artifact from when this wording is an artifact from when I took this class. And I've always hated it, so I will take this opportunity to change it. Because this is the absolute sector address of the very first sector in the partition. I hate this wording, and thank you for reminding me of how passionate I am because of this exact issue. Because it's not where it's very ambiguous how it's worded. Okay. Does that surprise anyone that professors don't create all original content every semester? You feel like I just told you the Easter Bunny isn't real or something? Okay. All right, so there is a second partition entry. I would like for you to practice on your own. Not right now. Okay? Sorry, question?
Yeah, so what you were saying, so then for like the second entry, we would do, or what was the whole plus 5 12 for the x08?
I'm sorry, I'm not following you.
You can ignore what I said.
Okay.
Yep.
Never mind.
Okay, all right, let me take a look here real quick. Okay, so here's the order of things how we're going to do them. I have one more slide, and then I'm going to introduce the homework assignment to you. I am going to. So Adam, the TA, is going to introduce to you. He's not here today. I don't know why I looked over there. He's going to introduce to you a really cool topic called. Oh, I'm interrupting the flow. Let's do the last slide. For heaven's sake, my goodness. Okay. Oh, that was it. Dang it. Okay. Okay. We're gonna stop right here for lecturing for, whoa, we're not leaving. We're not leaving, don't go anywhere. This is where we're gonna stop. But you need information from these lectures that we've done so far to do the homework assignment. So, but I'm not gonna finish this topic until next Thursday. That's what I'm trying to tell you, okay? So I will post up to this point in these slides later today so that you can start the assignment that I'm going to announce right now. And on Thursday, Adam is going to lecture you on what? Fishing forensics. Who just got really excited? That's fishing with a PH. Right? Okay, so Adam has done some really cool projects with PayPal. He knows his stuff, like specific to fishing. But here's the thing. So his lecture slides contain some sensitive material. Okay, not like explicit or anything. I'm just saying, you could break the law using information in his slides. So his slides are only accessible to ASU students. You're not allowed to copy them elsewhere. Okay. Everybody understand why? Okay. No? Because you could break the law using his, okay. Okay, so that's where we're gonna stop for the lecture. Let's talk about your first programming assignment. Okay, so in this assignment, your mission, whether or not you choose to accept it, is to write a program that analyzes master boot records and volumes, okay? So, you write a program, it's going to be executable like this, and you're going to pass, basically you have one argument to your program, which is the path to a raw image. We have a raw image for you. Click here, you will download it, but we need to unzip it first because it's basically 40 megabytes of mostly zeros. So I wasn't going to post a 40 megabyte file that could be zipped down to 41K, right? Who would do that? So I'm running through it again, I apologize. So you're going to take in a path to a raw image file that has been unzipped, and you're going to spit out some really cool analyses, very similar to MMLS. Are you allowed to use MMLS in your program? Yes. According to the syllabus, are you allowed to use MMLS in your program? You're forgetting the other two requirements.
Does it constitute a major part of it?
No, some of the other syllabus, yes. That would constitute a significant portion of your programming assignment. So no, you may not use MMLS in your program. Yes, you will be technically. All right, so a couple of things. You need to make sure that when you open the file, you open it read only. Anybody question why you would need to open it read only when you're dealing with forensic evidence?
Proof that you didn't write.
Yeah, it's kind of an important detail, right? When you're doing forensics, you open read only, always, always. The device, file, image, doesn't matter, always read only. Okay. Okay, the first thing that you're going to do after you open it read only is you're going to compute two checksums for the image file, MD5 and SHA-1. They both have limitations, but when you use them together, they're stronger, okay? So that's why we're going with both. You need to save them to files named MD5 and then the image name .txt and SHA-1-image name.txt. So if the image name is sparky.raw, then your module needs to generate MD5-sparky.txt. Is that clear? Okay. Now, you're going to read in the master boot record of this image. And you're going to extract the partition table and interpret it. And tell me 4 pieces of information. The hexadecimal value for the partition type, the English translated version of the partition type, the starting sector, and the size. Okay? Now, this is going to force you to do a couple of things. First of all, you're going to have to process data that is in little endian and convert it into big endian, right? Actually read it in properly as an integer. And it's going to make you, so this is the probably the most tedious part of this programming assignment, is getting what I have selected here, the NTFS, all right? Here's what we're gonna do. I am going to have you work together as a class on this one non-significant part of this assignment, okay? So there's a huge list of partition types available on Wikipedia. I'm gonna show it to you now so you can appreciate just how many this is and why I would have you collaborate with each other. This is the list of partition types. Just gonna scroll for a while. Oh, look, we're not even halfway. Okay, you get the point. There's a lot of partition types. Okay, now whether you write a scraper, whether you come in here and go to edit and pull out the raw source and then do something with it, I don't care. If you want to share with your classmates, I don't care, as long as credit.
And it doesn't contribute.
It's not a major part of your program and doesn't come from a previous or future student. No future students. Current students are okay for this one assignment. Okay? If you don't want to share it, if you got like this awesome way of pulling all this data down so that your program can use it, go for it. If you want to share it, go for it. I don't care. Clear? There's one programming assignment where I'm going to let you do this. Okay? But remember the three caveats, the three conditions that's possible. Okay? If you have questions about this, please post it on Piazza. If you don't want to share with the whole class at first, mark it private. Okay? All right. Just some notes on printing. You do need to do padding with zeros at the beginning, just so that it's easier for us to check. Yes, question.
One more question. These numbers are interesting. So
Yes, they are.
them from little Indian to big Indian.
Yes.
All right.
Yeah. Basically, so it may be easier than you think it is right now, but the important thing is that you make sure that you do it correctly. Okay? All right. So then for each partition, this is the other part that's a little bit tricky because reading in 512 bytes is pretty easy, right? It's great, right? Technology is great. So for each partition, you're also going to give me some information that is specific to that partition. You're going to read, so this requires you to interpret correctly the starting location of the partition, and then you're going to read in what is called the boot record. Did I say master boot record? No, I did not. I said boot record because it's not the master boot, because it's not the beginning, right? So every partition, pretty much every file, every partition type reserves the first sector for what's called a boot sector, for reasons that we'll talk about when we talk about file systems. I want you to read in the whole boot record and then give me the last 8 bytes of that boot record to prove to me that you got to the right place in the disk by understanding the layout of the volume. Questions? Yes?
How many submission attempts do we get?
Unlimited. Yeah, so grade scope, right? So I've talked, I think last time, about how we're going to use grade scope for programming assignments. We have not completed, it's not ready for you to attempt, but you can start programming, right? So once it's ready for you to attempt submission, it will run your code through a series of tests and give you a grade. If you're not happy with that grade, then you fix your bugs and you submit again. So it's like test-driven development, but where I write the tests.
Does it give us feedback on like what input we're failing for, or will it just?
It
tell us-
has that feature. I haven't decided if I'm going to give it. Yes. Yes.
So this is due in April the 20th.
Yes.
This is all of them we're gonna be doing.
What? That's not right. One second, please. Here, I'll do it like this. So you can see how I work. All right. Okay. By the way, this is on a Chromebook. Just throwing that out there.
What does the 611 stand for? Oh, yeah.
What branch am I on?
When is the
Oh,
intended?
yeah. Oh, yeah. February 15th. February 15th. It's there. It just didn't get compiled in this version that you're looking at. February 15th. February 15th. A week before the midterm. Everybody's still tracking the midterm, right? Okay, so you're gonna give me the last 8 bytes. So start to finish, again, this is notional. You execute this command. By the way, who knows where the $sign came from? You do? What?
Well, now that you said that, I'm like historically.
Yeah.
No.
Why does a Unix prompt show a $sign and not like a greater than sign?
Yeah. They like mine.
Anybody? No? A little trivia to use at your next cocktail party. The guy that came up with that, his dad made the game Monopoly. Yeah. Yeah. Not super nerd. Super user. Oh, it's all good. It's all good. Oh, it's okay. Okay, so, all right. Sorry for the tangent. Okay, so you're in Linux, right? And you compiled your executable. You're ready to test it. You run this against the sample file that we gave you. It's going to print out something like this. This is not the real output. Okay. I mean, the numbers actually do match up. I did do that. So the lengths actually do increase. So you're going to output the 4 partitions, and then partition type 1, last 8 bytes for that. Last 8 bytes of partition 2, 3, and 4. This is what your output should look like. It should be in this format. Okay? 11:59.
Yeah.
Yes. Okay. So Gradescope uses Docker, an Ubuntu 1804 64-bit Docker image. So one of the details that we have yet to iron out, like my ironing, is I don't know if we can run your make files. I'm not 100% sure. I don't know if we have super user privileges at that point in the running of your programs. So contingency is this. If that doesn't work, what we will do is we will collect the packages, because here we got, you need to submit this packages file with any Ubuntu packages that are required to run your code that aren't part of the baseline standard installation of Ubuntu 1804. What we'll do is we'll collect those from you in some, I'm not sure how, and we will inject those as requirements to the image before it runs your program. Okay? If that technical information didn't make sense, just know that we might need to work some details out before your program will run, if it needs anything special. Yeah, I didn't think we'd have this much extra time. Should we go back and finish the lecture slides? But we'll finally answer the question, what is a file? No? Any questions about the assignment? Yes?
We're doing some sector, particularly assume that sectors are 512 bytes.
Yes. Sectors are 512 bytes. Oh, yes, sir.
So if we get like stuck and need some like advice, we can ask you and you want to like push us along right away, or is it more of like
The syllabus addresses that question.
Yes.
You guys are giving up? Just kidding. Okay, that's fine. You can go early. That's fine. If there are no other questions. All right, we'll see you next time, guys.